Hello everyone, I'm Harshini and Raj studying in Sri Venkateswara College of Engineering, Bangalore. I'm currently in 7th SEM in the Department of Information Science and Engineering. And in today's video, we'll be studying about the RSA algorithm. First, what is RSA? RSA, that is a Rivest-Shamir-Adleman algorithm, is an asymmetric cryptography algorithm. Asymmetric actually means that it works on two different keys, that is public key and private key. As the name describes, that the public key is given to everyone and the private key is kept private. An example of asymmetric cryptography. A client, for example, for example, browser sends its public key to the server and requests some data. The client receives the data and decrypts it. Since this is asymmetric, nobody else except the browser can decrypt the data even if a third party has the public key of the browser. This is a simple representation of how RSA key is encrypted and decrypted. First, we have a Bob. Bob has public key rings that is of Joy, Mike, and Alice and Teddy. This is the plain text input which is sent into the encryption algorithm, that is the RSA, and the Bob will have the public key. Now Alice wants to access the input text, so the input text is transmitted into ciphertext and stored in Alice's private key. This is how the encryption with private key is done. Now with encryption with private key, when this is the decryption. Now the plain text is sent with Bob's private key where the encryption algorithm is applied. Then the transmitted cipher key. Then Bob's public key is used to find the plain text. Essential steps. Each user generates a pair of key to be used for the encryption and decryption of messages. Each user places one of the two keys in the public register or two accessible files. This is the public key. The companion key is kept private. Each user maintains a collection of public keys obtained from others. If Bob wishes to send a confidential message to Alice, Bob encrypts the message using Alice's public key. When Alice receives the message, he decrypts it using his private key. No other recipient can decrypt the message because only Alice knows the Alice's private key. This diagram shows how the explanation to these 2 points. The idea behind RSA algorithm. The idea of RSA is based on the fact that it is difficult to factorize a large integer. The public key consists of two numbers where one number is multiplication of two large prime numbers, and private key is also derived from the same two prime numbers. So if somebody can factorize the large number, the private key is compromised. Therefore, encryption strength totally lies on the key size, and if double or triple the key size, the strength of the encryption increases exponentially. RSA key can be typically 1024 or 2048 bits long, but experts believe that 1024-bit key could be broken in the near future, but till now it seems to be an infeasible task. This shows how the RSA key is the working of the RSA key. RSA algorithm uses the following procedure to generate public and private key. First, it selects two large prime numbers, that is P and Q here. Then multiply these numbers to find n is equal to P into Q, where n is called the modules for encryption and decryption. Next, we are going to choose a number E less than n such that n is relatively prime to P minus 1 into Q minus 1. It means that E and P minus 1 into Q minus 1 have no common factor except 1. Choose E such that E is less than 1 is less than E, and E is a prime number, prime to sigma of n. GCD E comma D of n is equal to 1. If n is equal to P into Q, then the public key is E comma n. A plain text message M is encrypted using the public key EN. To find ciphertext from the plain text, following formula is used to get ciphertext C. C is equal to ME mod n. Here M must be less than n. A larger number, that is which is greater than n, is treated as a concatenations of messages, so each of which is encrypted separately. To determine the private key, we use the following formula to calculate the d, such that de mod p minus 1 into q minus 1 is equal to 1, or de mod phi of n is equal to 1. The private key d comma n, a cipher message C, is decrypted using private key d comma n. To calculate plain text m from the cipher text C, following formula is used to get plain text m, that is m is equal to cd mod n. Let us take some example of IRSA encryption algorithm. Step 1. Select two large prime numbers p and q. Here we are taking p as 7 and q as 11. Step 2. Multiply these numbers to find n is equal to p into q, where n is the modules for encryption and decryption. So n into that is 7, n is equal to p into q, that is 7 into 11. So therefore n is equal to 77. Step 3. Choose a number e that is less than n, such that n is relatively prime to p minus 1 and q minus 1. Choose e such that 1 is less than e minus sigma of n, where e is the prime number to sigma of n. So second, we calculate sigma of n is equal to p minus 1 into q minus 1. Phi of n is equal to 7 minus 1 into 11 minus 1. Phi of n is equal to 6 into 10. And phi of n is equal to 60. Let us now choose the relative prime number e of 60 as 7. Thus the public key is e comma n, that is 7 comma 77. And step 4, we are going to apply me mod n formula, where me is 94 mod 77, that is 37. Therefore, C is equal to 37. Step 5. The private key is d comma n. To determine the private key, we use the following formula, such as p minus 1 into q minus 1 is equal to 1. 7d mod 60 is equal to 1, which gives d is equal to 43. The private key is d comma n, that is 43 comma 47. Step 6, we're going to apply the formula, that is m is equal to cd mod n into the numbers which we found. So 3743 mod 73, that where m is equal to 9. This is an example where plain text is equal to 9 and the cipher text is equal to 37. And that's all in today's video. Thank you for watching.